Hi everyone, welcome back to lesson 1-2, which is about two variable equations. This one we will do right out of your Springboard book. It will start on page 7. So go ahead and open to that and follow along with me. So lesson 1-2, two variable equations. First up, our learning targets are to create equations in two variables to represent relationships between quantities and to graph two variable equations. So what we did yesterday and in the last video was one variable equations where we only used x. And I think today you might even find that it'll be a little bit easier because it'll be more so what you're used to, which is two variables. So for example, y equals mx plus b, when you guys see equations written like that, that is a two variable equation. Okay, so let's start out here. It says, at Sapphire Island, visitors can rent inner tubes to use in several of the park's rides and pools. Maria works at the rental booth and is preparing materials so that visitors and employees will understand the pricing of the tubes. Renting a tube costs a flat fee of $5 plus an additional $2 per hour. All right, so let's go ahead and move down to number 1. And it says, Maria started making a table that relates the number of hours a tube is rented to the cost of renting the tube. Use the information above to help you complete the table. Okay, so again, we know from up here the key pieces are that there's a flat fee of $5 plus an additional $2 per hour. So no matter what, if you rent the tube, it costs $5. And then if you rent it for an hour, it's going to be that additional $2. So the cost for 1 hour is $7. Okay. Then if you rent it for 2 hours, well, the cost per hour is $2. So you're going to have to add $2 there. So $9. 3 hours, add another $2. So $11. 4 hours, add another $2, so $13. And 5 hours, add another $2, so $15. Okay, so that's what your table should look like there. Then number 2 says, explain how a customer could use the pattern in the table to determine the cost of renting a tube for 6 hours. Well, we went through and did the table all the way up to 5 hours. So we know 6 hours would be pretty easy. That should just cost $2 more. So you would just continue the pattern by adding $2 to the renting for 5 hours. So it would cost $17 to have your tube for 6 hours. Next, Maria wants to write an equation in two variables, x and y. That employees can use to calculate the cost of renting a tube for any number of hours. Some of you may already have that idea of what the equation should look like in your head, which is great. But before we do that, let's talk about these variables a little bit more. So if you look over here at this math tip, it says, recall that in a relationship between two variables, the value of the independent variable determines the value of the dependent variable. So hopefully you guys have heard of these terms before in either another math class or maybe even a science class. And it says here, what does the independent variable x represent in this situation? Okay, so in this case, when talking about our tube rental, the x is going to represent the number of hours the tube is rented, because this will determine the cost, which is why it is the independent. Okay, so if you need a little bit more time to jot down these notes, go ahead and pause the video at any time. I would recommend doing that. Okay, well, we're going to keep moving here. So then obviously number 4 is asking, what does the dependent variable y represent in this situation? And well, obviously if x represented our number of hours, then y is going to have to represent the cost in dollars of renting a tube. And this makes sense because the cost depends on how many hours you're going to rent the tube. So your cost is your dependent variable. Okay, and we'll keep talking about those as we move forward. But now it's asking us to write an equation that models the situation. And what we did in lesson 1.1 may help with this a little bit, but we know for sure that x is going to represent the number of hours, right? So let's go ahead and write that off to the side, just like we were doing in the last lesson. Number of hours. So we also know that it costs $2 per hour. So I'm going to write that as 2x, $2 per hour. But we also know that we have that flat rate or flat fee of $5, and that's just for the tube. Okay, but now in this case, it's asking for an equation, and we don't have an equation yet because there's no equal sign. So we also know that y is going to represent your cost. So we know that if we put this all together, it's going to equal y, or your cost. So that should be your equation. And again, like I said, some of you may have been able to come up with that on your own. Okay. All right. Number 6 says, how can you tell whether the equation you wrote in item 5 correctly models the situation? Well, you could take any number that we plugged in the table on the last page and try that out. So for example, back in this table, if we're thinking of this as x and this is y, let's say we plug in 3 to the equation for x and we should get out 11. So let's just double check that. So we plug in 2 times 3 plus 5. And 2 times 3 is 6, plus 5 is 11. So like we said there, that works out. And you could do that with any of the values in that table and it would have worked. Okay. All right, awesome. So moving on to number 7, it says, explain how an employee could use the equation to determine how much to charge a customer. Well, obviously, using an equation is going to be a little bit quicker than going through the table and adding 2, adding 2, adding 2. So if someone wanted to go for like 11 hours, you would quickly be able to plug in 11 for X and get your Y or get the cost. So it would just help an employee figure out the price a little bit quicker. Okay, cool. All right, let's move right along here. It says here, Maria also thinks it would be useful to make a graph of the equation that relates the time in hours a tube is rented and the cost in dollars of renting a tube. So for number 8, it says to list 5 ordered pairs that lie on the graph of the relationship. So those could again just be from the table. So we had 1, 7, 2, 9, and so on and so forth. You can list those 5 from the table. Okay. So then if we go to graph on the next page, we could obviously go and plot those points. So like I said, we had 1, 7, oh, hang on, 1, 7, 2, 9, and so on and so forth. Is there another way that once we know an equation, we could plot those points or we could graph this? And I want you to take a second to think about that. So without ordered pairs, how else could we graph something like y equals 2x plus 5? All right, so here's a quick look at what your graph should look like when you're finished. Okay, and to answer that question I just asked, this might be a little bit of review, but this value here, or if you're thinking about it as y equals mx plus b. That's the b value, and that's also known as your y-intercept. So basically what that means is that is your starting point, starting point on the y-axis. So that's one thing there. And then this part here is your m, or your slope. And you probably remember slope is like your rise over run. So I know the numbering is a little bit different here, but this goes up 2 and over 1. Again, based on how it's counting. So up 2 over 1, up 2 over 1. So that's just another way that you could graph it if you did not have all of the ordered pairs already ready for you. Okay? So there's your graph of a two-variable equation. Okay? Now we have a couple questions going along with those graphs, or with that graph that we just did. So number 10 says, based on the graph, explain how you know whether the equation that models this situation is or is not a linear equation. Well, first of all, looking at this line here, this graph here, it looks like a line, right? So that's obviously a dead giveaway that it's linear. But another big part of this is that we know this equation is linear because the graph makes a line and because it has a constant rate of change or slope. So this is key here. We're going to be talking about this part quite a bit. Okay. And again, that slope is the m value. So it's that $2. And we know that that cost is going up by $2 every hour, no matter what. So it's a constant rate of change. Okay. All right. Then this one says, explain why the graph is only in the first quadrant. So let's just talk about the quadrants really quick. You have your graph like this, or your Cartesian plane. This is quadrant 1, quadrant 2, and they use Roman numerals, quadrant 3, and quadrant 4. Okay, so it's asking, why are we only in this quadrant here for our graph? And let's think about that. Okay, so if we go back up, look at what we're labeling this: number of hours and cost. So does it make sense that our number of hours rented or our cost would be negative in this case? No, not really. So that's exactly why your answer for this should be the graph is only in the first quadrant, because X is time and Y is dollars or cost, and we cannot have negative time or money. So they only used the first quadrant for the graph. Okay. Then 12 and 13 we talked a little bit about. 12 says, what is the y-intercept? And if we look back up here, we said the y-intercept was 5. And that represents the flat rate. So it says, describe what the y-intercept represents in this situation. And that is the flat rate that it costs to rent the tube. Okay. And then it also asks here, what is the slope? Which again, we jotted down as the 2. And that represents that the slope is always like per, right? So it's what you're either spending per hour or how quickly you're moving per hour or something like that. It's always going to be a per. So in this case, it's the cost per hour of renting the tube. And you could be as specific here as you need to be, but it's the hourly cost. Okay. All right, so that's pretty much it. That's a very basic example of how to come up with an equation and how to graph that equation for a two-variable equation. Last thing I would like for you to try, and I know it says work with your group here, but I want you to try to think of your own description for a scenario It could be related to the water park, or you could be even more creative. For y equals 40x minus 8. So that's another two variable equation. And just try to come up with somehow how you would involve that minus for the y-intercept and have a slope of that 40. Okay? All right, so once you've done that, that's it for today. Please let me know if you have any questions, and be ready to dive a little bit deeper into two variable equations during our Zoom tomorrow. Thanks, have a good one.